In this video, you will learn what is Kruskal-Wallis test and assumptions for Kruskal-Wallis test and how to build research question according to your data and how to build hypotheses for Kruskal-Wallis test and how to perform Kruskal-Wallis test using SPSS and interpretation of the results. The Kruskal-Wallis test is a non-parametric statistical test used to determine if there are statistically significant differences between the median of 3 or more independent groups. It's the non-parametric alternative to one-way ANOVA and is used when the assumptions of ANOVA are not met, particularly the assumption of normality. These are the key points for Kruskal-Wallis test. Kruskal-Wallis test compares the distribution of the groups rather than their means, and it does not assume a normal distribution of the data. The test is based on the rank of the data rather than the actual data values. These are the assumptions for the Kruskal-Wallis test. First assumption: independent observations. The observation in each group must be independent of each other. Second assumption: ordinal or continuous data. The dependent variable should be measured on an ordinal scale or a continuous scale. Third assumption: 3 or more groups. The test requires 3 or more independent groups for comparison. Fourth assumption: similar distributions. The distribution of the groups should have a similar shape of the Kruskal-Wallis test to be appropriately interpreted. Let's consider a dataset where 3 different teaching methods are being compared to evaluate their effectiveness on student test scores. Let's build our research question according to our dataset. So this is our research question. Is there a significant difference in student test scores across the 3 different teaching methods, method A, method B, and method C? You can build your hypothesis like this. Null hypothesis: there is no significant difference in the median test scores among the 3 teaching methods. Alternative hypothesis: there is a significant difference in the median test scores among the 3 teaching methods. This is our dataset and we have 2 variables, teaching method and test marks, and 1 for teaching method A, 2 for teaching method B, 3 for teaching method C. And then go to Analyze, then Non-Parametric Test, then Legacy Dialog, and click K Independent Sample. And put our test marks into test variable list and put teaching method into grouping variable and click Define Ranges. So our minimum range is 1 and maximum range is 3. And click Continue and tick Kruskal-Wallis H and click OK. So this is our output results. Let's interpret the results. The chi-square value of 6.489 indicates the degree of difference between the groups. The larger this value, the more likely it is that there are significantly differences among the group medians. The p-value is the probability of observing the data if the null hypothesis is true. Here, the p-value is 0.039. Since it's less than our commonly used significant level of 0.05, we reject the null hypothesis. So, what does this tell us? Since our p-value is below 0.05, we have enough evidence to conclude that there is a statistically significant difference in the test scores across the 3 teaching methods. This means that at least one teaching method is likely more or less effective than the others.